G'day guys, we've got a chemistry exam question today which has been given to me by one of my students. Now, it's asking us to determine the empirical formula of a compound. Now let's just read through the question where we have quantitative analysis of an organic compound showed that it contained only carbon, hydrogen and oxygen. A quantitative study of the same compound was performed in which that many grams sample was burnt in excess oxygen to produce this much water, this much carbon dioxide, collected at 100 degrees and 102.8 kilopascals. Now, determine the empirical formula of the compound. So it contains only carbon, hydrogen, and oxygen. So basically, our empirical formula is going to take the form, we've got the amount of carbon, it's going to have some kind of amount of carbon, some amount of hydrogen, and some amount of oxygen. And we've got to try and figure out what this is. Now, I've got a certain style of which I like to go about doing these empirical formula questions, especially in exams. But before we start, let's convert everything that we have to our standard units. For example, we have this 100 degrees Celsius here. This is going to be 373.15 degrees Kelvin. And this 700.7 mils is going to be pretty simply 0.7007 litres. Okay, so now we've converted everything that we need to convert. The way I like to do these empirical formula questions is in a table. Now, what I mean by that is we're going to work out the amount of carbon, hydrogen and oxygen separately. So let's draw ourselves a quick table. Okay, so the reason I draw a table is because it breaks up my working out into three distinct areas, and it makes it easier for me to understand at the end when I'm trying to actually work out the empirical formula. So let's start off with carbon. Now, the carbon, we're going to find out the amount of carbon that this thing has from the amount of carbon dioxide that is collected. Okay, so what we can say first is the number of moles of carbon is going to equal the number of moles of carbon dioxide that is collected. Now, we can work out the number of moles of carbon dioxide that's collected using this relationship. We've got PV is equal to nRT. So naturally, N is going to be equal to PV divided by RT. Now, this is equal to the pressure, which is 102.8, times the volume, which is 0.7007, all divided by the universal gas constant, which is 8.314, times the temperature, 373.15 Kelvin. Cool, and this gives us a number of moles of carbon to be 2.18 times 10 to the negative 2. Now, I would get used to writing things in scientific notation, guys, because it's just the easiest way to express things. So you don't have to write 0.00000. You can just express it like this. It's a lot neater, to be perfectly honest. Now, when we find out the oxygen, we're going to need the masses of both of these. Now, so to work out the mass of carbon that we have, that's just going to equal the number of moles times the molar mass, which is equal to this thing here times by 12.01. So that's quite easy to do on the calculator. We get 0.27885. grams. Cool. So let's move on to the hydrogen. So the number of moles of H2O that we collect is going to be equal to the mass of water that we collect divided by the molar mass of water. So 0.416 divided by the molar mass of water, which is 18.016. And that gives us a number of moles to be 2.309. 0.309 times 10 to the negative 2 moles, then that's of water. So to work out the number of moles of hydrogen that we have, the number of moles of hydrogen is equal to 2 times the number of moles of water. So we multiply the number we've just got, this 2.309 times 2, and we get 4.6181. Times 10 to the negative 2 mole. So that's the number of moles of hydrogen that we have. We also have to work out the mass of hydrogen. And that's going to be equal to the number of moles of it times its molar mass. So we're going to times by 1.008. And we get 4.655 times 10 to the negative 2 grams. And that's of hydrogen. Now, let's move on to oxygen. Change colour again. Now, first off, we need to figure out the mass of oxygen that we have. Now, we can't use any of the products of this combustion reaction, only because it's burnt in oxygen as well. But what we can do is, the reason that I've figured out the mass of both hydrogen and carbon is because I can take these masses away from this sample that we have up here to get the mass of oxygen. So I can say that the mass of oxygen is equal to that sample mass, 0.5096, subtract these two added together. So we have 0.27885, forgive me for going outside the table, plus 4.655 times 10 to the negative 2. Close that bracket down. And we get a mass of oxygen to be 0.184 grams. Now it's fairly easy to work out the number of moles of this now. We have the number of moles of oxygen to be equal to its the mass that we have, 0.18423, divided by its molar mass, 16. And that gives us a number of moles of 1.1514 times 10 to the negative 2 mole. Cool. Okay guys, now we have the molar quantities of the carbon, the hydrogen and the oxygen in this 0.5096 gram sample. So what we're going to do, because the empirical formula is a formula that gives the proportion of elements present in a compound, but not the actual numbers or arrangement of the elements, what we're going to do is we're going to work out what the ratios of each of these elements are to each other. So first of all, let's just go ahead and write down each of the molar amounts of each of these compounds. So we have 2.309 32, 18 times 10 to the negative 2. We have 4.6181 times 10 to the negative 2 moles, and we have 1.1514 times 10 to the negative 2 moles of oxygen. Now, the best way to get the ratio of each of these to each other is to find the smallest molar quantity, and this is going to be our 1. So what we're going to do, what I mean by that, is we're going to divide each of these amounts by our smallest molar quantity, which is in fact the oxygen. So we have 1.1514 times 10 to the negative 2. And when we do that division, that's going to equal 1. We've got 1.1514 times 10 to the negative 2. And when we do that division, it's pretty easy to see that's going to be 4. And we're going to have 1.1514 times 10 to the negative 2. And it's pretty easy to see when we do this division that we're going to get 2. Now these are all approximate. You might get 2.01 or something like that, or 1.99, but it's approximately 2. Use your best judgment with that. So after we've got these ratio amounts, we can then say, therefore, the empirical formula is equal to C2H4O. Cool. So let's just quickly run through what we did. First of all, when I was reading the question, I converted all of the different quantities to our standard index units. So I converted the mils to litres, degrees Celsius to Kelvin, and then I basically, after I did that, I divided all of the different elements that I have in this compound into a little table. So here I had 3 different elements. I had my carbon, my hydrogen, and my oxygen, and I divided them into this table. Now, the reason I did that is when I came back to work out what my molar amounts were or anything like that, it was a lot easier for me to find. In an exam situation, you might not think this makes a difference, but let me assure you, it makes a difference. Okay? So once I did that, I found that the number of moles of my carbon came from the number of moles of carbon dioxide that were produced. The number of moles of hydrogen that I had came from the number of moles of water that were produced, but then I had to multiply it by 2 because of the nature of the water molecule. And what I did is I worked out the mass of both the carbon, the hydrogen that I had, and I subtracted that from the total on my sample to work out the mass of the oxygen that I got, which is there. Once I did that, it was quite simple to find the number of moles of oxygen. Once I did that, I used the smallest molar quantity to give myself a ratio. Now, if you get rather than a 4, if you got like a 4.5 or something close to 0.5, you know you're going to have to multiply everything by 2. But in this case, we got all nice round numbers, and we finished up with C2H4O as our empirical formula. So, it's a pretty hard question, guys. In an exam, this one was worth 10 marks, so you have to dedicate a bit of time to it. But I hope my video helped. I would recommend using this table. It has worked for me in the past. It's also helped me identify any mistakes that I've made if I'm having to quickly run back and cross-check. But, it's up to you guys which way you go. I hope you enjoyed this video. If you did, give it a like. Subscribe to my channel. I put out new videos all the time on chemistry, maths, physics, whatever you like. And until next time, guys, enjoy your studies.